numbers is a list. I like to use dir a lot to find a directory of the methods, or rather the associated functions that support the type of the value stored in the variable. So the type stored in the variable numbers is a list. I'm asking, what are the functions available to a list? We have append, clear, copy, count, extend, and so on. So what that means is, for example, I can say numbers dot count, right? I'm sorry, it's a property. Gives us basically a sort of a function that allows us to count the presence of values. So 2, the value 2 happens to occur only once. So we can also do numbers dot up to pop out the next value for us to process, and thereby shortening numbers, right? So if you call numbers dot pop again, it pops out a hyphen, and then it's one element shorter. So how do I know that these dot function calls are available? They are basically just done by dir numbers, but remember, it's not about numbers, it's the value, rather the other way around, the type of the value that is being stored in number. So if we say something like dir of a list type, and that's fine too, we get to see exactly the same set of support. Okay, but that's detouring a little bit. What I'm after is this method called copy. So another very helpful tool I use a lot is, what is there any help, that is built in for us to see what's a copy? It's very skinny, right? But basically it makes a copy of the list. So if you supply a list of one item 2, it's going to duplicate into a new copy. But here, this example is not very clear because we can't tell which is which. What is clear is here, okay? Suppose we don't pass in numbers. I hope this part we have gone through many times. I've slow motion down, I've paused, I've reminded again and again, right? So hopefully you're very clear here. But suppose we don't pass the numbers there, but we pass a copy of the list that is stored in numbers. Okay, so what we are doing is, let me flip back. We are asking Python to make a copy. So numbers.copy. Yeah, numbers.copy. Make a copy, then pass it in as list of its. When we do that, this is where the confusion comes, but hopefully now you're very clear. When we do that, we are really explicitly asking Python to scan through one by one and make a photocopy of it, all right, and build a new list or a new dictionary or a new set or new tuple and so on and so forth. The dot copy makes a photocopy of it, not photo, but memory copy of it. And thereby creating a new pointer wherever necessary. So when we do that and we pass in the copy itself will make Python create a pointer because it's a list, right? It's a copy, but it's also a list. So Python will make a pointer to the copy version of the list, not the original list. So now what is going to happen is detect prime is going to receive not a list, a pointer to a list, right? So it's going to point at the copy somewhere that is otherwise unpointable. That means no one else can look at that thing. So somewhere in the memory there's a list that's 2, 3, 4, 5, 6, 7, 8, 9, and the only way we can talk to that, we can read it, write it, and modify it, is already passed to list of ins. So remember, when we exit the function, everything is destroyed, right? Including list of ins, including the reference to that, which means that list is no longer accessible. It's gone. So what happens then? We're going to, the function detect prime is going to receive 2, 3, 4, 5, 6, 7, 9. It's going to calculate 2, 3, 4, 5, 6, and cancelling off 4, cancelling off 6, 9, and so on. But that is done to the copy. What happens to numbers? No change. You're right. No change at all. So what we expect is this time round 2 to 9 and then 2 to 9. No change at all. Precisely because we're not touching numbers, right? It is so this version is as good as saying pass in a copy of numbers, but let's call that globally as numbers 2. So numbers 2 is photostated from numbers. Now it's pointing at, it contains the list. We pass in a pointer to numbers 2, which will modify and reset 4, 6, 8, 9. And so numbers itself is not going to be modified, but because we have a global storage of numbers 2, just now we didn't, but now we have, we are able to now check what is numbers 2. And so numbers 2 is like our previous numbers. Basically, it's going to be modified. So if you run it, numbers itself is not changed, but numbers 2 is going to be modified just like before. Just like before. So this is the most confusing part, which I hopefully find that you're not confused because you followed through the discussion, you understood how Python has chosen to do efficient assignment. That itself alone, all right, creates all these consequential side effects. And that is why without knowing that behavior, that implicit built-in behavior that is actually not mentioned anywhere, but it's probably documented somewhere as pass by reference. But if you didn't understand those words, you're going to be very frustrated, very confused, very angry for something that is actually pretty straightforward. All right, so hopefully now you're tracking what we are discussing and therefore not finding it unreasonable. All right, so just to quick summary again is that Python only makes a copy for structured data types. Remember, the reason why we only deal carefully with structured data types is because it potentially can be gigabytes large, right? One class can contain maybe 1 GB large kind of data, properties, methods, and etc. So if you always, as a standard default behavior, make a copy of everything, it is going to be quite insane in terms of memory usage. So as a kind of a standard design philosophy or whatever you call it, Python always makes efficient assignment. And that efficient assignment technically is called pass by reference. Okay? And we spoke about return value, and all functions return a value, like in this case, right? So again, let me just copy and paste this into all functions return a value, return area, and not returning also has a return value. This is what I want to share with you. Okay, so we have area of office, show greetings. Yeah. So as we saw just now, earlier on, there is a point in not trying to compactize our code. There's only a one-liner. Why do you need to functionalize it, make it a function called show greetings? Might as well just print hello, how are you directly here, right? And yes and no, because when you do that, next time when you want to have elaborate hello, how are you, depending on the time of day, good morning, good afternoon, depending on your location, maybe you will change the language to Chinese or Japanese or Russian or whatnot, depending on the locale you're in. You want to have complicated show greetings. You no longer have that luxury because everything is laid out sequentially, right? There's no clarity in the logic. But here, we might start off test running our code with a simple print hello. But later on, we want to make the show greetings friendlier. And we have a very logical, systematic way to do that. Just go to the function called show greetings. Next, this show greetings clearly tells us, the programmer, not the user, right? Clearly tells us, the programmer, that we are trying to show greetings. So it doesn't have to be very complicated. It implies a lot of things that programmers somehow know, and it therefore has a clarity in the logic, and that's what we want. But back to this return and no return situation. Why is it that return functions with no return values still return something? Let's inspect that something, right? Okay, we try to capture what is not being returned by show greetings and see what is being shown. And the value is called none. So it's a sentinel. So sentinel is a value used with special meaning. It means nothingness. Okay, so nothingness is so nothingness that we ask Python, is none implying zero? No. So zero is implying zero, yes, but none is not the same as zero. Well, is none the same as false? Can I take false as none, none as false because they are semantically equivalent? Answer is no. All right, so none is this singularity that it stays on its own, but it is so profoundly important. It has no arithmetic, uh, no meaning whatsoever except none. Noneness. It's not even of any zero-ness in any sense. Is none the same as empty string? Definitely not, right? Is none the same as none? It is only in this particular case that, yeah, because if you are telling me I have singularity and he is telling me he has singularity, I would not try to confuse myself by saying this is your singularity, none of his problem. All right, so basically none is equal to none. It's called quite a lot of profound implications if you define none is not the same as none. So all these have been basically trashed out. I just want to show you quickly so that you won't be surprised next time when you try to run the logic and say if none is equal to zero, then do this. Well, you know that that can never be true, so there's no point checking at all, right? Something like that. Okay, so now that we have assured ourselves that even when we return nothing, like in show greetings, we did not return at all, there is one value that is being returned. Okay, that's called none. So just to show that it is actually being returned, we first assign a value of 5 to value, right? But after assigning the return result of show greetings to value, we see that value itself has been reset to none. And that's something to keep in mind. I know that some test questions usually ask print, all right, print show greetings, and they will say what is being shown, what is being shown. So maybe you are lucky you get multiple choice questions, or you're not, then you have to type out what is being shown. And most students will get it right and say, we will see hello, how are you, question mark being printed out. But that is when you call the function, right? The function does that. Then it finishes, and although you didn't return anything, it returns none, which is then substituted here. And what happens then? We'll see a none. All right, so if you do that, you will see a none. So if you actually print the result of show greetings like this, you should see hello exclamation mark space space, how are you question mark, next line, none. That will then be the final correct answer, right? So this is pretty tricky, but not so if you understood that a function always returns a value. Even if you didn't return explicitly using a return, it returns none.